is Rob Steenburgh. I'm a forecaster and space scientist at the Space Weather Prediction Center, part of the National Weather Service in Boulder, Colorado. So today I'm going to talk about the effects of space weather. Space weather involves phenomena from our nearest star, the Sun, that impacts Earth and the Earth environment. And not only does it impact our environment, but it impacts society as well. So today I'll talk a little bit about some of those impacts. Space weather begins at the Sun, and one of the most common occurrences, particularly when the Sun is very active during its 11-year cycle of activity and quietness, are solar flares. These flares are large eruptions from the Sun that occur when magnetic fields in the Sun get twisted up and eventually break and reconnect. That breaking and reconnection releases tremendous energy in the form of electromagnetic waves, visible light, X-rays, ultraviolet light, and radio waves. We detect them here at Earth using weather satellites equipped with space weather sensors that detect these X-ray flares. The immediate impact of an X-ray flare is felt in our ionosphere, a layer of the atmosphere that is used to reflect radio waves for high-frequency radio communications. During a flare, the ionosphere can be disturbed to such an extent that high-frequency radio communications are not possible, or are only possible on a limited set of frequencies. Some users of the high-frequency radio spectrum include aviation and amateur radio operators. In addition to solar flares and the X-ray effects on our ionosphere, you can also get solar radio bursts. These radio bursts can occur on any frequency, but they pose a problem if they occur on a frequency used by GPS. And this has happened before and resulted in outages for that very important system. Additionally, associated with flares and another phenomenon called coronal mass ejections are energetic particles, protons and heavy ions, that come streaming from the Sun and can arrive at Earth in minutes to hours. These particles can impact satellite operations and cause malfunctions, and additionally, they can represent a threat to our astronauts on the International Space Station. Consequently, part of SWPC's role is working closely with NASA to ensure the safety of the astronauts aboard the ISS. Finally, the coronal mass ejections, which are giant blobs of plasma ejected from the Sun and occasionally end up coming to Earth, create geomagnetic storms. And these geomagnetic storms are a consequence of the magnetic field that's embedded in the blob of plasma that's ejected. When it gets to Earth, it can cause a geomagnetic storm. And these geomagnetic storms, if they're of sufficient magnitude, and they're very rare magnitude I'm talking about, but if they're sufficiently strong, they can impact the electric power grid. And power grid operators have to take actions to mitigate the effects of these geomagnetic storms. That's another role that SWPC has in alerting these operators to take the necessary actions to protect the grid. Additionally, these geomagnetic storms can impact pigeons, which use the geomagnetic field for navigation. During geomagnetic storms, pigeons can get lost. And so you don't want to have a pigeon race during a geomagnetic storm. One of the phenomena associated with space weather events, and actually the only visible manifestation of a space weather event, is the Aurora, which you'll see near the polar regions, both the North and South Pole. In those high latitude regions, you can see lights in the sky, and they can be of various colors, from greens and reds to purples. If a geomagnetic storm, which produces the aurora, is strong enough, the aurora can move equatorward and actually be seen in places as far south as Cuba for a particularly strong geomagnetic storm. So there may be a time when we have geomagnetic storming that you'll actually be able to see the aurora. Why do we have space weather forecasters? Because as society has evolved and we've started to use technologies that are based in space, it's become important for us to pay attention to the environment around Earth as well as on Earth. So, quick review: solar flares and radio bursts impact the ionosphere and radio communications. Energetic particle events can affect satellites as well as humans in space. And finally, geomagnetic storms can impact the power grid and pigeons, among other things. Thank you.